So we're just going to continue with what we did previously. Remember, we had a 1.21a and we did it all three ways. Same thing, we're just going to do another problem. What I'm hoping is that this time you are feeling a little bit more confident when you see it. So in algebra, we're going to set it equal to each other. So I'm going to take those two equations, negative x squared plus 9x minus 14, and set it equal to 2x minus 4. Now, I want to remind you that in the previous time, I moved everything to the left. Why did I move everything to the left? Because I want my x squared to be positive. Does it have to be positive? No, but life is easier when things are positive. So I want to play that same game here. If I moved this stuff over here, my x squared would stay negative. So I'm actually going to take all of this and move it over there. And let me show that in algebra we set things equal to each other. Okay? So now that means I'm going to go plus x squared, which this doesn't look like anything, so I put it over there, minus 9x, and plus 14. And some of you go, why are you showing work this time when you move it? Well, it's a little bit more complex. It's not as easy for me to do it. So I have 0 on the left. Is it okay that 0's on the left? Yeah, you can switch it. What needs to come first? X squared minus 7x plus 10. Let's see if you remember what to do. What did we do last time? Magic X. Let's do the magic X. Two numbers that multiply to get 10 and add to get negative 7. So 1, 10, 2, 5. Which one's going to give me 7? This one. Whatever this guy is, the bigger guy gets it. But if this is positive, they both have to be negative. So x minus 5, x minus 2, x equals 5, x equals 2. Am I done? No. I'd be done if the problem was this, just factor. But I'm trying to find where they cross. I'm going to be making a what? A U that goes down and a line that goes up and seeing where they cross. Let's think about those scenarios. So one scenario is it crosses twice. Another scenario, so that's 2 times. Another scenario is it just crosses once. And of course the last scenario is, hey, they don't touch at all. So it's going to be they touch twice, once, or 0. How many times do they cross, intersect? Well, twice, because I got 2 x's. So I know that one of them is 5 comma something, and one of them is 2 comma something. And you go, okay, well, what do I do now? Do I plug it into all this? No. Do me a favor. Take these two, plug them back into one of these. Do you think I'm going to pick the F, or do you think I'm going to pick the G? You're right. I'm going to pick the G. Am I going to show my work if this is a quiz and homework? Heck yeah. So I'm going to go 2 times 5 minus 4, 10 minus 4, 6. And then I'm going to go 2 times 2 minus 4, 4 minus 4, 0. Okay? So now I know my 2 points of intersection are 5 comma 6 and 2 comma 0. So now that I know that, it's going to be easier for me to fake it over here, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then 2 comma 0. So I know that's where they cross. Now, some of you go, well, what do I do now? Well, I know one of them's a line. If I connect these two, it makes a line. Let's see. To graph this, you go down 1, 2, 3, 4. Up 2, right 1. Up 2, right 1. Yep. I can graph the line, no problem. And notice how I'm putting this in yellow because I don't want to forget that my parabola is going to cross there. Okay? Now this one is not as easy for me to graph, so we're going to worry about that one later, okay? So, but I just wanted you to see that I saw that. Now how do I do the table? Well, what x values do you think I'm going to pick? I'm probably going to start with 2, then 3, 4, 5, 6. That's probably enough. 2, 3, 4, 5, 6. Do I know the y values of some of them? Heck yeah. 0, 0, 5, 6. And some of you go, then why do I have to do the rest? Well, you need to show that if you didn't know that you could still figure it out with guess and check. But I bet we would agree algebra is a little bit easier. But this is a different way to represent it. And some of you go, why would I need another way to represent it? You all say hello 5 million different ways. Okay, it's nice to have different ways. We all speak millions of different languages. It's nice to represent things in different ways. It helps us understand things better. Okay, so this one I'm going to make f of x, and this one I'll make g of x. Now, which one do you think is easier for me to plug in? Do you think it's going to be easier for me to plug in f or g? Yeah, you're right, g. Okay, so let me get some, because I don't really have as much space, so I'm just going to use graph paper. Blank paper. So I'm going to try the 3. So I'm going to go 2 times 3 minus 4, 6 minus 4, 2. Does that mean that's the 2? No. They only cross at 2, 0 and 5, 6. Every other number should be different unless you made a mistake. Now try 4. 2 times 4 minus 4, 8 minus 4, 4. Okay, and some of you go, how do you know you did it right? Look, there's a pattern. Plus 2, plus 2, plus 2. And look, it's the pattern. So I know the next number is 8. Anybody know what the next number is? 10, 12, 14, 16, 7, 8, 9, 10. And some of you go, is that necessary? Well, is it necessary to understand if you're correct or not? Yes, it is. It's necessary for you to see that linear equations have patterns. You worked on that a lot your freshman year, okay, or 2 years ago. All right, now a parabola. We know that one's not going to be as easy, so I will go more slowly. This is going to be negative x squared really means negative 1 times x squared. Okay, hold on, I have to pause it because my computer's about to die. So remember before when we were doing exponents and I said negative 2x, and I said it really means negative 2 times x? So negative x really means negative 1 times x. Same thing, okay? By the way, let you see the squared is not touching the, or it is touching the x, but not touching the negative. So let's go back. I'm going to plug in 3. So I'm going to go negative 1 times 3 squared plus 9 times 3 minus 14. Based on PEMDAS, exponent times that is negative 9. Multiply that. 18 minus 14 is 4. Okay? Do the next one. Negative 1 times 4 squared plus 9 times 4 minus 14. So 4 squared, negative 16 plus 36. I know I'm going quickly, but this should be review for you. Okay? And then let's do the 6. Negative 1 times 6 squared plus 4 times 6 minus 14. Do you always need to show your work? Yes. That's how I know you did it yourself. That's how I understand if you made a mistake, where your mistake could be. I feel like I made a mistake somewhere. Okay, let me pause it really quickly. Okay, so I figured out my mistake. I was going so fast I didn't read the 9 as a 4. So let's try this again. 54, and then 54, 18. Positive 18, 4. And some of you go, Miss Rifkin, how did you know you made a mistake? I know that this makes a U, which means the Y values should match up, because I remember that. If these two matched up, these two should match up, which means if this is a 7, does anybody know what number it's going to be? 0, it should be. So this can match up. That means the vertex is right in the middle at 4.5. Okay? So if you're kind of lost on that, you might need a review on that, but I think we go over it either later in chapter 1 or chapter 2. All right, so 1, 2, 3, 1, 2, 3, 4, 4, 6, 5, 6, 6, 4, 7, 0. Now, if you draw it like this, that's not a U. Okay, let me zoom that in a little bit. The vertex is somewhere in the middle, and it's faked a little bit, okay? But I'm just not going to be, I have a lot of good qualities, and drawing is not my best one. Excuse me. But you know what? It's okay that it isn't my best quality, because you know what's great? I can represent it through a table, I can show you the points, and I can show you the algebra. Okay? So now that we did that, let's step it up a little bit more. Now they're saying, hey, I want you to take F and add it to G. So I come over here, I take F and I add it to G. So I'm going to go negative x squared plus 9x minus 14 plus 2x minus 4. And I literally just add them up. Oops, you can't see that. Sorry about that. So I added them, this plus this. And I'm showing it vertically. It's easier for my brain. But you can still write it all horizontally. That's fine. Now they want you to do the same thing, but they want you to subtract. Okay? Now, when you subtract, remember when we had subtraction, if you had like 3x plus 5 minus 2x minus 4, what does that really mean? Change the signs of everything to the right, do the opposite. So that's what you're doing here. You're going to change the signs of everything to the right. Negative x squared plus 7x minus 10. Okay? And then this one says, hey, set them equal to each other. So you're going to go negative x squared plus 9x minus 14 equals 2x minus 4. That's exactly what we did up here. So the answer is 5, 6 and 2, 0. Okay? All right, let's check out this next page. Ah, we're at the homework. Perfect. Okay, exactly what I just did on the previous page, which is probably why I did it, is what you're doing there. Oh my gosh, it's dealing with exponents. Have we done exponents before? Yeah. What is this? Solving? Maybe make sure you factor it first. And what I would do is make sure that it says equals 0 equals 0. So think about what you're going to have to do in order to get that one. They want to know, where does this graph cross the x-axis? Graph it. Okay, it says use Desmos and set it equal to 0. Okay, let me give you a separate example. What they want you to do is, if I gave you, I don't know, q of x equals x squared plus 9, and I said solve, you would make that a 0. Then you would subtract 9, and then you would square root. And remember, whenever you square root, because it's a squared, you're going to do plus or minus. But the problem is, there's a negative. So, what does negative mean? It means it's square root of -1, which is your I. And then what's the square root of 9? 3. And some of you go, Miss Rifkin, you went too fast. I'm telling you, you guys have learned a lot before you met me. Okay? And so these are all review questions. If it's an issue, bring it up in Zoom. Okay? And it's okay to bring it up, by the way, because people struggle in imaginary numbers. All right, so that covers that. And let's look at the last page, solving. You know how to solve. The two ways to do this one is make an x, multiply what touches, or what I would do is I would multiply everything by 35. Let me show you what I mean by that. What I would do, let's say 7x minus 2, x plus 7, 6, 3. Yeah, that's fine. So I would actually multiply, let me make it a different number. Let's make it, I don't know, sorry, I just went blank. This and, I can't even think of numbers anymore. Let's go 8 and 6, okay? So what I would do is I would actually multiply by 24. And the reason I'd multiply by 24 is that's how I would get rid of those fractions. 8 goes into 24 3 times, distribute, distribute. 6 goes into 24 4 times, distribute, distribute. Now the fraction's gone, solve it. And some of you go, I don't want to do it that way, I'll just make an x, multiply what touches. Great. But when you get more difficult problems and you don't understand this concept, then you're going to struggle in that problem. So being able to do a problem a multitude of ways is good for you. If you're struggling on it, talk to me about it in Zoom. Okay? This is finding the slope. I don't know if you remember, that's y2 minus y1, x2 minus x1. The way I taught it, if I was your teacher, was finding the difference between those. The length is finding the distance. There's two ways to do that. There is a formula, but I don't like formulas. I literally plot the two numbers I'm making up. I don't know where they are. Let's say it's here. And I make a triangle. I figure out how long from here to here, how long from here to here, do the Pythagorean theorem, and figure it out. Otherwise, use a formula. Midpoint. Midpoint means find the middle. So what's halfway? Okay, I want to know what's halfway. All right, this thing's about to end. To do an equation, use homework help. Okay, this one I'm going to skip, and then this is all exponents. I made it.